For the last page, we are going to review problems from section 11.5, the last section of the chapter. So the first 3 problems on this page ask us to find the midpoint of the line segment with the given endpoints. So to do this, we need to remember the midpoint formula, which is x2 plus x1 over 2 and y2 plus y1 over 2. You could also write x1 plus x2 over 2 and y1 plus y2 over 2. It doesn't matter. Either way, you'll get the same answer. So let's take a look at 15. So for 15, we're going to add the x's together. So we get negative 2 plus 9 divided by 2. Made the parenthesis a little big there. And then we have negative 4 plus negative 4 divided by 2. So negative 9 plus 2 would be 7 divided by 2. And negative 4 plus negative 4 is negative 8 divided by 2. So our final answer, you can leave it as 7/2 or you can write 3.5. So 3.5 comma negative 4. For number 16, I'm going to zoom in a little bit so I have a little bit more room to write. We have negative 8 plus negative 8 over 2 and 0 plus 2 over 2. So that gives us negative 16 divided by 2 and 2 divided by 2. So our midpoint is at negative 8 comma 1. We have our last one over here, number 17. So 6 plus 4 divided by 2 and 1 plus negative 5 divided by 2 gives us 10 divided by 2 and negative 4 divided by 2. So our final answer is 5 comma negative 2. The last 2 problems deal with the distance formula. So let's write down what the distance formula is because we need to be able to memorize that for the test. So the distance formula is D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so let's take a look at this problem. A triangle has vertices at the coordinates 3, 5, 3, -1, and -2, -1. Find the lengths of each side of the triangle. Well, since they gave us a bunch of coordinates, let's graph this triangle, and then we'll see if we can find the distance. So, make a little graph right there. Oh, I'm going to have to go up to 5. So let me make the graph a little bit different so I can get up to 5. 1, 2, 3, 4, 5. Okay, that should work out for us. So we have a point at 3, 5. And we have a point at 3, -1. And we have a point at -2, -1. So if we connect all those points, we should have our triangle. Okay, so it looks like that it's pretty easy to tell the distance between the point -2, -1, and 3, -1, because we can just count. So it looks like it is 1, 2, 3, 4, 5 apart. So we can call that side A. So we can say that side A equals 5. And it looks like it's pretty easy to tell the distance between 3, -1, and 3, 5. So we can count up 1, 2, 3, 4, 5, 6. So we can say that that's side B. But we don't really know the distance between -2, -1, and 3, 5 because it's not a straight line. But we can use the distance formula to help us figure that out. So I'm going to do the distance formula down here. So for x2, we're working with these 2 points right here, -2, -1, and 3, 5. So for x2, I'm going to plug in a 3, and then I want to subtract a -2 and square it. And then for y2, I'm going to plug in 5 and subtract a -1 and square it. So I get that the distance equals 3 minus a -2 is a +5. And 5 minus a -1 is a +6. So I get the square root of 25 plus 36, which is the square root of 61. And we can't simplify the square root of 61. You could put it in your calculator and tell me what the decimal is. But we can just say that side C equals the square root of 61. So now what we need to do in part B is use the converse of Pythagorean theorem to see whether or not the triangle we drew is a right triangle. So we can use a squared plus b squared equals c squared to help us figure that out. We know that side A is 5, and we know that side B is 6. And we can plug root 61 in for c squared. But remember to square it. So 25 plus 36. And remember the square root of 61 squared is just a regular 61. And we end up with 61 equaling 61. So it checks out, and we know that, yes, this is a right triangle. Okay, moving down to the last problem. So the distance D between 2 points is given. Find the value of B, and we have the coordinates B, -6, -5, 2, and D equals 10. So we're going to use the distance formula again to help us with this problem. So we have D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So for x2, I'm going to plug in a -5. And for x1, I'm going to plug in b. For y2, I'm going to plug in 2. And for y1, I'm going to plug in a -6. All right, and for D, we can plug in 10. So let me erase this D, and we'll put a 10 in there, since that is the distance. Okay, so I want to get rid of this square root. So I'm going to square both sides. So now I have 100 equals -5 plus b squared plus 2 minus a -6 is the same as 2 plus 6, which is 8, and 8 squared is 64. So now I can subtract 64 from both sides and get 36 equals -5 plus b squared. Now I need to get rid of the squared, so I'm going to take the square root. And remember, when you take the square root when you're solving, we get plus or minus 6 equals -5 plus b. So we need to set up two equations. The first one is positive 6 equals -5 plus b. So if we add 5 to both sides, b will equal 11. And the next one is -6 equals -5 plus b. So if I add 5 to both sides, b equals -1. So we have two answers for b. b equals 11 and -1.